could find if they or if they're parallel, because then they won't have a...
Yep, so if we have two equations that are linear, like you said, we could find if they're parallel.
Is there a check for perpendicular as well?
Yep, perpendicular. We could find when they intersect by simultaneous equations. Do you remember that? So we could find if they're parallel, perpendicular, we could use simultaneous equations to find the intercept, if there is an intercept point. Three situations for two equations. They'll have no intercepts. So if there's no intercepts, they're going to be parallel. Ladies, do you remember the other solutions? So there are no solutions. There could be one solution, and that's when you use simultaneous equations. Or there could be, so they're the same line, so they just intersect at every single point. Singular matrix.
Oh yeah, something like that. Oh, I need to get my other book.
Correct. So we use matrices to find these solutions.
Yes.
M number and the N number. Okay? So like it says in this example, the M number is the number of equations we have in the question. And the N number is how many variables in those equations. Like the maximum variables. Because some of the equations might only have two variables. Does that make sense? So it might just have x and y, but then another might x, y, z, and then another one w, x, y, z. Or something. So m is equal to 2. How many variables? 3. M does not equal n, therefore not a square system. Now, I could be wrong here, but the significance of a square system is you are able to solve it. So the left-hand side does not equal the right-hand side, so it's not valid. And n is equal to plus 3, that's a negative 2. Therefore, valid. Okay? So that's like the basics.
You flip A and D. With the negative, obviously, the little t.
No, transpose is you. Transpose is you flip B and C. So I'm going to introduce you to a new one. It's called an org matrix or an augmented matrix. So it looks like this. So it's like, it could be like a 3 by 3. And then it has like this extra column at the end with a line separating it. So something like that. So this is an augmented matrix. We'll talk about that tomorrow though. Alright, so we have AX equals B. How do we solve for X? So you need to convert it to the inverse. So you may remember the determinant is AD minus BC. Is it 12, 14? One, then the second row by the first column. What does the 2 and 4 mean?
That's where they.
A bit of revision. I'm going to use my calculator. So you've got this little matrix. Oh no, that doesn't work because we're doing a 3 by 3. There we go. And do you remember how to assign something? So the double dot equals. So I've got an A, so I can do the inverse of A. Oh, exciting. Alright, so let's do, I've got to find a B first. What was the B? The B is a 3 by 1. Oh no, it doesn't have a 3 by 1 shortcut.
Click on that one and then it takes you to
Which one?
yeah, the one, that one.
That one?
Yeah, and then you can put it in.
Ah. So 3 by 1. Let's type some stuff in. 25. So Gaussian elimination, we'll do that tomorrow. If you want to kind of read ahead, there's a video on OneNote if you want to watch that before tomorrow. Otherwise, have a go.